In a recent video, I used a Python script to generate random gibberish. I needed a baseline for some data I was analyzing. I ran the code, it spat out thousands of random characters, and when I plotted the word frequencies on a graph, it drew a flat horizontal line. My comment section immediately tore that control group apart. Now, I didn't know if their critiques were going to hold up mathematically, but honestly, there is nothing I like more than learning something new, being corrected, and finding compelling evidence to confirm it. It makes me learn even more. A lot of you argued that using a machine to simulate human nonsense was a bad test. You theorized that if a human sits down to write pure gibberish, they will subconsciously repeat patterns and that text will naturally follow Zipf's flaw. If you aren't familiar with Zipf's flaw, it's a mathematical rule that shows up in almost every natural language. When you graph a real language, it creates a very specific downward diagonal slope. So I decided to put you to the test. I built a temporary website, dropped a link, and asked you to give me pure brain slop. I gave you two options. Strategy number one was the keyboard smashing, or literal face rolling, hitting the spacebar occasionally. Strategy number two was fake language, actively trying to invent words from your brain on the fly. Now, I left that site up for a few days, and close to 200 of you actually did it. You generated over 10,000 words of data. I spent some time reading through the raw spreadsheet, and some of the things you guys sent were hilarious. Now, we had people mashing their keyboards in Cyrillic, we had people mashing in Arabic. One person literally submitted the lyrics to Princess Sol That, which is a 1970s Italian song written specifically to sound like English, even though it's complete gibberish. Others went all out and invented languages complete with some punctuations and apostrophes. Thank you to everyone who participated. You gave me exactly what I needed. Now, I took all of your submissions, split them up by the strategy you chose, and run them through the exact same Zipf's flaw script I used in the previous video. And here's what came up. You guys were 100% right. Neither of these lines are flat. They both slope downwards. And this is where dozens of you pointed out a massive flaw in my logic. Python scripts are mathematically random. Human beings, on the other hand, are not. To understand why this graph looks the way it does, we have to look at how computers and humans handle randomness. In the previous video, my code generated a flat horizontal line because a computer is unbiased. If you tell code to spit out random syllables, every single fake word has the exact same chance of being generated. Word number 1 shows up 5 times, word 100 shows up 5 times. When everything ties, the line stays perfectly flat. Uniform chaos is horizontal. Now, humans don't work like that. We have a repetition bias, and it shows up in two different ways depending on the strategy you picked. Look at the cyan line, the keyboard smashers. It peaks incredibly high on the left side of the graph. That happens because of the physical hardware sitting on your desk. Your hands naturally rest on the home row, and the spacebar is massive. Because of that physical constraint, people actually hit the spacebar at regular intervals and typed the exact same short chunks like ASD or JKL dozens of times. The hardware forced the math. You didn't type randomly. Your keyboard's layout decided the word frequency for you. Now look at the magenta line. These were the people actively trying to invent a fake language. You are trying your hardest to be random, but the line still slopes downwards. This is a psychological constraint. Thinking up completely unique words is mentally exhausting. Inventing 1 or 2 fake words is easy, but getting to the 50-word minimum I set on the website requires some cognitive effort. Now, so the brain cheats. It invents a fake word for the or a cool-sounding prefix, and then just recycle it to fill the page faster. Now, that mental fatigue creates high-frequency repetitions, and those repetitions build the exact downward slope you see in real human languages. Now, you'll notice the lines on this graph look like a jagged staircase dropping off a cliff at the end. Don't worry, the math isn't broken. That is just what happens with a small sample size. That long flat line at the bottom represents words that were typed exactly one time. In linguistics, these are called hapax legomena. We only had about 10,000 words total. If I waited until we had 100,000 words, you would eventually start reusing those single words. The stairs would smooth out, and the graph would look exactly like the curve for the English language. So, what does this actually mean? Well, it means we tried to create pure chaos, and we failed. Whether you literally face roll a keyboard or actively try to invent a language from scratch, you cannot escape Zipf's flaw. Your physical limitations and your mental fatigue force you to repeat patterns. And this actually ties up a loose end for me, bringing me back to a certain 15th century book I covered recently. People look at the Voynich manuscript, see a complex language, and assume it must be real or highly advanced. But as you guys just proved to me, passing Zipf's law doesn't prove it's a real language. It just proves a human wrote it. A guy trying to churn out 200 pages of fake magical text to scam a rich duke wouldn't need to be a mathematical genius to pass this test. His tired brain would just do the math for him. Anyways, thanks for watching, and I will see you in the next one.